Okay. First of all, thank you for coming to this presentation, and thank you, Alejandro. Having two daughters, there's a lot of information now. I can socialize with them and go eat.
Life.
Yes,
Great.
yeah.
Bro.
So my topic is really talking about a physiological monitor and a garment type that we developed for the Air Force, and so we'll go through some of the learnings and let's see where it goes. So we're gonna give you a brief introduction, talk about how we approach the solution and some of the results and next steps. So basically, for the DoD, it's very important the human performance, and especially for the Air Force and their pilots monitoring their physiological state. And they didn't have really an equipment that could do that effectively. So they reached out to us to develop a garment that could support that. We developed PHYSIO, which is part of our TacMON ecosystem of physiological monitoring garments. This one specifically was designed with flame-retardant material, which brings their own quirkiness, if you want to use that word. And of course, integrating e-textile technology and to combine all the sensors and bring them to a central place for data collection. A little bit about us. We're a very small company. We're located actually in the greater Boston area. We're about 35 minutes away from here south. We have this nice, we're located in the top 2 floors of that beautiful paper mill in Walpole area. We have 35 people and 40,000 square feet of a playground for engineers and technologists to develop this type of technology. Our focus is really developing hardware, embedded electronics on garments. And as many as you know, and I bet you know, it's a huge challenge. We have 2 business types. One is a wearable computer, which is really focused for the government to develop power and data management with edge computing capabilities. And then the other one is base layer electronics, where we have some commercial industrial success with developing gesture glove and other things. So let's talk a little about why this. Sorry. Something skipped there. So the Air Force pilots were reporting hypoxia-like conditions as they were flying. Actually, some of them were passing out. They lost control of jets, and at one point, the Air Force had to put a pause in flights, and especially on the F-35s and T-6. So that free funding, because they couldn't consume fuel, so they decided to focus and give attention to what's going on with the pilot. So they wanted to instrument the pilot more than they already had done inside the cockpit. And they worked with Netflix and us to develop this garment. So like I said, PHYSIO is a variation of our TacMON ecosystem. Our TacMON ecosystem said we developed this garment a few years ago. It's basically an architecture, open architecture. We support male and female users, multiple size, different styles of different materials, etc. It's an ecosystem because, of course, you have all these other complementary things to support the tool. Specifically on PHYSIO, the challenge was to make it of no melt, no drip material. If you're not familiar with the government, there are also some government standards that we need to comply, like the Bear Amendment, which means all textiles have to be made in the US. So those constraints on the material limits how the design, the fit of the shirt is. So the other part of it, they had a selected suite of sensors they wanted to integrate. And that led us to using some of the technologies we'll discuss here. So other implementation challenges, as you can imagine, is the flame-retardant material is not very nice. Some of the other synthetic and nice material that you see in the commercial apparel world. Because trying to make it more conformal, it uses some spandex and other latex material that is not very stable for manufacturing processes that we were utilizing. Of course, sensor location is critical for this to perform properly, and it has to interact with the pilot assemble. So they, they carry vests, other kind of